is full of math. I don't have any room for anything else.
So, sorry, just tell me again one more time. It was section 3.5, number 303. 303 says, oh boy, all right. Marisol left Los Angeles at 2:30 to drive to Santa Barbara, a distance of 95 miles. So, Marisol left LA at 2:30 to drive 95 miles. Traffic was heavy until 3:20. She drove the rest of the way in very light traffic and arrived at full 20. Let's just say arrived full 20. All right, so that's the beginning. It already sounds exciting, right? Her speed in heavy traffic was 40 mile an hour slower than her speed in light traffic. That kind of makes sense. So I got heavy traffic, light traffic, right? Speed. So her speed in heavy traffic was 40 mile an hour less than light. So which one's just X? Her speed in heavy traffic was 40 mile an hour less than the speed in light traffic. So which one's just X?
Light traffic.
Light traffic. Sneeze happen. It's okay. Speed in heavy was 40 mile an hour less than light. I gotta know what this is first, and then what's heavy. 40 mile an hour less than this. 40 mile an hour less than this. What's that?
X minus 40.
X minus 40. If I gave you a number and then I said, what's 40 less than the number? So here's a number, 120. What's 40 less than that? What would you do? 120 minus 40. So here's the speed. I want 40 less than that. X minus 40. All right. So this is where I would definitely use that little chart I told you guys about. Can you guys see how this breaks up naturally into two main parts? What are the two parts of her trip? The part when she was in heavy traffic, and the part when she was in light traffic. I like it. Distance equals rate times time. So I know these are my unknowns, so it goes into the rate. So heavy traffic was X minus 40, light traffic was X. Is that cool? Maybe. Does either one of these get 95? Was either one of these 95? That was the total distance she went, right? So eventually I'm going to add these two to get 95. That's where the formula is going to come from. I do know times though, right? So how long from 2:30 to 3:20? 50 minutes. What's wrong with that? It's going to be a little weird. Isn't her speed going to be in miles per hour? So all the times we use have to be in hours. So 50 minutes is how many hours? Yeah, maybe something close. Not really. 50 minutes. How many minutes does it take to make a full hour?
60.
So we only have 50 out of 60. 50 over 60. So this is 50 over 60 hours. Wait, what was this one? This was, yeah, this is heavy, right? 50 out of 60, which is 5/6 of an hour. How long was she in traffic after that? This is nice. She was in light traffic for how long? An hour. Am I saying that this is easy? No, but I am saying if you break the problem down into what is it that's an unknown? What do I know for sure? I know times for sure. Let me just focus on that piece, get that done. The big mistake I see is people put 50 here, but then it's almost like she traveled for 50 hours. Oh my God. Can you imagine traffic being that bad? Well, it's almost gotten that bad. Move an inch, 3 hours later. Another inch. What goes here? Yeah, because distance is rate times time. X times 1 is x. And then this is going to be a little gross, but those will be 5/6 times x minus 40. And what did we say earlier has got to happen with these two distances? That's what those are, right? Those are distances. What are those two distances supposed to do? Add up to be 95. That's the total distance she went. So I think part of this is your desire to have the problem done so you can be closer to being done with homework, making you want to do this quicker. But also sometimes I feel like students think you're supposed to be able to do this quick. No, you got to break it down into its parts. Okay, that was definitely, that's like the last problem. That's one of the hardest problems in that section. So that's not supposed to be like easy.
I think doing a problem really quickly is fun because then you know the problem.
Well, I mean, sometimes doing a problem quickly means you're done, but then you got the wrong answer quick, which is, you know.
Well, what I'm saying is, like, usually if you know how to do the problem quickly.
Oh, I see.
Yeah.
It's always
then you
nice.
know.
Quick and right is good.
Yeah.
All right, anything else from homework stuff?
27 on 4.1.
4-1. Where are you? There you are. 27? Oh, okay. I don't like you over there. Come here. There we go. So this one gives you this equation. And then it gives you a table to fill in. Dadgummit. I think you're working. Let's see. And let me see. The table I think was 0, 0 to -2. I want you guys to realize something. These inputs are kick-ass. 0 definitely. You just always use 0, right? Because that would just kill that piece. That's easy. Bam! Look at that. Watch. Put a 0 in. -2. Done. You guys see that? Because if I put a 0 in, that whole piece dies. So that's a gimme right there. Why are these inputs really nice? What's the worst part about that equation? Yeah. But if I put multiples of 2 here, don't they? Yeah. So you just now, so if you throw a 2 in, those cancel. So you get -3 minus 2. Bam. Is that the question? Or did they want you also to? No, they just wanted you to fill in the table. Yeah.
I just do that.
Oh, man.
I don't want to.
So in the future, if I gave you a problem like this, and I said, make your own table of values for this, and somebody give me, well, one smart input to always use is 0. What's another smart one to use here? 5. And then another one, -5 or 10. I'm not going to put 3 in there. Right? You guys see that? We can choose. Why can we choose? Because how many points does the line go through? How many points does any line go through? Infinite number. And I only need a few of those. So I can get any of those I want to be able to graph a line. Yes?
Could you go over the part where you, what is it, where you're supposed to cancel out, what is it, the 2? Is that-
Well, I mean, if you throw a 2 in, so negative 3 halves times 2 minus 2, what do the 2's do?
Oh, cancel each other.
Yeah. So then you get negative 3 minus 2, negative 5. Okay.
I kind of
I like it. I like it a lot. Okay. Anything else from homework stuff? Now remember, what's happening tomorrow that your crazy teacher told you? Yeah. This is the sort of like the week of I don't know. It's the WOQ, the week of quizzes. You're welcome, by the way. And I'm not being facetious. You want more grades. I felt bad that I only gave you 1 quiz before that first test. So now I feel better, and you're all like, whatever, it's all about you. It is. Yes?
Can we make corrections on the quiz?
Yeah, of course. Yeah. What do they do to get maximum points?
For the next exam.
Next test, yeah, I like it. Which is, I think, next Tuesday, right? So tomorrow I'm going to have the practice test for you. Oh, Jabeezus.
I think if you really care, you have a quiz every day.
Ooh, Curtis, let me make a note. Everybody loves that idea. Man, you are not making friends. Anything else from homework stuff? Okay, so I want to do a real quick review because I want to unleash you on this little group worksheet. Let's see. All right, here's something real quick. How do I check to see if that line goes through that point? If it does, what should happen?
4 would equal 4.
I love that. In general, if any line goes through some point, then these values should work in the equation, right? How do I get a set of values to graph a line? I plug something in and I get something out and I plot that point. So, think about it backwards. If I have a point that I think goes through the line, I plug it in to see if it works. You guys with me? So you don't have to graph anything up here. So if I do plug these in, now this is where I did this on purpose. Let me see if anybody, so it'll be 2 times,
2.
good. Don't just put them in, this is X, this is Y. So it'll be 2 times 2 minus,
3 times 5.
is this true?
No.
So does that point belong on that line? No, that line will not go through that point. So if you did do this though, it works. 10 minus 6 is 4, right? But that isn't Y, that's X. That isn't X, that's Y. You guys with me? In fact, watch this. If I had a similar problem, what do you got, Jeff? I don't know, man. Gotta keep coming up with these things. Yes. Screw it. It doesn't matter. Doesn't matter. You gotta make the point. Okay. It's the same question, right? Just without the words. What goes in here? What do you guys think? The 2 goes there. I love it. So any point that is given to you, the coordinates go in alphabetical order, unless stated otherwise somewhere. So this doesn't state otherwise, therefore this must be B and this must be C. You guys get that? Just like X and then Y. So the general rule is if it doesn't say something else, you assume it's alphabetical order. Just in case somebody does that to you somewhere, like me on a thing. Yeah, you never know. Okay, I like it. We've done stuff like that. I'm not going to do more of that. Here's the little thing. How do I find intercepts for a given situation? How do I find x and y intercepts? What does intercepts mean? What do they mean? What's the x-intercept? It's the point where what happens?
Where two lines intersect.
No.
Where x is 0?
No. I think I just said the x-intercept, right? So just not even on a mathematical idea. What's the x-intercept? It's where the line does what with the x-axis. It's where it intercepts the x-axis, right? So that's why we call it x-intercept. So you have a line. If I draw a line, bam, it could have a y-intercept. It could have an x-intercept. Now you're going a little bit further. You're saying, how do I find them? What's true at any x-intercept? If I draw a bunch of lines here, what's true about every single one of these x-intercepts? What's the value of y? 0. I didn't go up or down at all. I want to stay on the x-axis. So to find the x-intercept, I make y 0. And to find the y-intercept, incredibly enough, I make x 0. Blah, blah, blah. So, for example, if I had, how do I find the x-intercept here? I make y 0. There we go. So then what do I get? 4x minus 5 times 0 equals 80. 4x equals 80, right? Because 5 times 0 is 0, right? Let that die. And then divide by 4. What point is this now? 20? That's not a point. 20? 0. To find the y-intercept, you do the same thing, except you just make x 0. Like it. In my key. So let's try this. Here we go.
No.
This is it. You got the great divide there.
It's not.
For sure.
You wouldn't hurt yet. All right, so you guys can work together. You can work a little.